Hey everyone, welcome in. Today we're going to be staying in the flames with the newest video model Wan2.1. It's been really exciting to mess around with this model this past week, and today I've got a video for you about how to train the model to follow what you want to see out of it even better. All right, so let's jump right into it. So I have a post up on my Patreon about this. All you really need from this is the 3 files at the bottom. I use Patreon to host my files completely free. Just head to the link in the description and you'll have access to these files. The other thing that we are going to need, so this is the Wan2.1 model website. That's also linked in the description. And then we need the Diffusion Pipe GitHub project. So Diffusion Pipe is a project by TD Russell, and this is what we're going to use to train the Wan model. And the cool thing I've heard about this model is that it actually works with, if you train the text to video, it works decently well on the image to video. So if there's like a specific motion that you want to see out of image to video, then you can train it on text to video, and then it should work on image to video as well. All right, so let's get into the training here. So I'm going to be using Visual Studio Code to run through the training. I think it provides just the best interface for you guys to follow along, and it works on both Windows and on Linux. So since I'm running Linux and a lot of people are running Windows, I think that this is just a good way to kind of level the playing field. If you have a better suggestion for what interface to use when I'm doing these more code intensive tutorials, then let me know. I'd love to hear it. The first thing we want to do is we need to come up with a data set, right? So we need to figure out what do we actually want to train this model to do. And I have just some black and white images that I have created, and I actually have both images and videos. I'm going to be training with images today. You can definitely train with videos also. The reason I'm using images is it's just a lot faster, and I've heard that the issue with Hunyuan, where if you used images you wouldn't get very good motion, is much better in Wan. So we're gonna go for images. As always, you can definitely try videos as well. I'll show you when we get to that point how you differentiate between whether you're using images or whether you're using videos. Okay, so I have training clips here, but I also have training images. So I'm going to bring my images in here. And all these are 512 by 512 stick figure drawings that I made just with like a paint application. So I'm expecting kind of like a black and white drawing type Lora out of this training. All right, so the next thing we need to do is we need to get our images ready to be trained. So I'm gonna start up Comfy UI real quick. Okay, so this is a really simple, helpful workflow for resizing all of your images. So it just resizes the image, and then because we turned keep proportion off, it just crops the center of the image so that it's 512 by 512. If you wanted to do videos, you could do the same thing. You just need the load video and save video nodes. Combine video nodes. And you just hook it up like this. And then it would resize all of the frames in your video to give you a cropped video. All right, so that's a really helpful tip, I think, for using Comfy UI to modify your images and videos for training. So I already did this with all of my data set, and now I'm left with 512 by 512 images that I'm going to do my training with. So here's all of my images. The next thing I need to do is create a caption for all of these. So I am actually going to navigate into this training images folder. Okay. So we can see all of my images listed out here. And then you can do this next part manually. I'm going to use ChatGPT to just create these text files for me. All right, so I used ChatGPT and I asked it to create a text file with my trigger word in it for every PNG in a folder. And then I'll also probably, I just want to name it. So rename all of the .png files and to stick x and name the .text files in the same way. Stick x.txt. So this one should do the trick. I just have to copy it into my terminal down here, and you can see it. So it renamed all my files, and then it created a text file with the trigger word in it. So I'm not going to do a lot of talking about how to caption. That's an art form, and we could probably have a whole video about the effect of captioning on Loras, but just using the trigger word works well enough for demonstration purposes. If you want to get into Lora captioning, it's kind of like learning a new language. So go for it. There's tons of resources out there online. All right, so we have our data set now. The next thing we need to do is get our diffusion pipe up and running. If you go to my Patreon, I have this install diffpipe.sh. Open that up. And all of these commands, except for this one, this hfd command, which downloads models, should work on Linux or Windows. It's just Git and Python commands. So let's run through it. We're just going to copy them one by one. All right, so first command is git clone -s recurse submodules of the diffusion pipe repository. So we're cloning this. We're essentially just following the directions on the website. We're going to clone it, and then we're going to install the requirements.txt. And then that's really all you need to do to get the code for diffusion pipe working. All right, so let's clone it. Next thing we're going to do is navigate into the diffusion pipe repository. And then we're going to set up a virtual environment for Python 3.11 and call it venv diffpipe. Next, we're going to activate that virtual environment. Then we're going to just update the installer tools in Python. And then we're going to install the requirements.txt. And you can see that we now have this diffusion pipe folder within our VS Code environment with our VM diff pipe virtual environment. All right, so requirements installed. One thing, I've already installed this before, so I had a cached version of Flash Attention. But if you haven't installed Flash Attention before, that install takes like 10 to 15 minutes to build the wheel. So don't get discouraged if it seems like it's stuck there. It'll work itself out. There's one last thing I need to do because I'm running on a 5090. So if you're also running on a 50 series GPU, you need to install the nightly version of Torch for CUDA 12.8. So I'm going to go ahead and do that. So my install has completed. Before we set up our configuration, we are going to download the models. So I already have the models downloaded. It takes a while to download them. So I downloaded them once when I first started playing with this model, and then I just move them around wherever I need them. But if you haven't downloaded them already, you need the full repository. You can't just download the VAE safe tensor file and text encoders. You need the full repository. So go ahead and download that however you typically do. Then we'll meet back up here. All right, so here's my model folder with all of my models. I'm going to drag that into the diffusion pipe directory. All right, so now it's in here. And then we are going to set up our config files. So I put some config files on my Patreon. You don't have to use these, but I think they give you a good jumping off point. So download these two files, the Wan config and the Wan dataset, and then drag those two files into your diffusion pipe folder. All right, so now we have these two files here on the bottom. And what you're going to do is first we need to set up an output directory. So this output directory here is where your Loras are going to go when the training is occurring. So I recommend pointing that directly to the ComfyUI Loras folder. So that's what you can see here, that I have it pointing towards my ComfyUI models Loras folder. And then I just subfolder it to organize my files a little bit more. But I would recommend pointing it to your ComfyUI models Loras folder. Then we have our dataset config file. So we put it in our root directory of Diffusion Pipe. So it's under our Diffusion Pipe folder. We have our Wan dataset file. So that's what it's asking for, where that file is. And then these are commented out. You don't have to deal with these. Epochs, just leave it high. We're going to do checkpointing, so you can stop the training at any point and resume it. Most of this you can ignore. If you know that it's going to take a while for your training to converge, you can increase the warm-up steps, and it won't start saving the training until these warm-up steps have completed. Eval settings, just leave all of these as is. And then miscellaneous settings, you can save every epoch, especially if you're trying to get like really fine-tuned to like find the perfect epoch. I'm going to just do every 5 so that I don't end up with like 1,000 epochs on my device. This will give me like 200 epochs. And then you can either checkpoint every n epochs, or you can checkpoint every n minutes. I usually leave this around 30, and then I come back and I check the training around every 30 minutes or every hour, and then I can stop the training, free up the GPU and do my testing, and then resume the training if the testing doesn't go well. Okay, the rest of this you can leave. All right, so next we're looking at our checkpoint path. So because we put it in the Diffusion Pipe path, all we need to do is just call out the folder, because it's using the relative directory. It'll be able to find this folder within the Diffusion Pipe folder. Okay, and the last setting that you might want to change is this learning rate. So I have it set at 5 e to the minus 5 right now. I would recommend the highest you go is 1 e to the minus 4, maybe 2 e to the minus 4. That'll train really fast, but you might miss that like perfect range for training. I think if you go 5 e to the minus 5, it kind of gives you a good happy medium between training too fast and training taking forever to converge. All right, so we can save that wan.config.toml file, and now we can head over to our wan dataset.toml. All right, so our resolutions, our images are 512 by 512, so we'll keep the resolution at 512. If your images were bigger, say, like 768 by 768 squares, then I would do it like this. If you want to do height and width, there's a description just below this where you would do it like this. So double brackets with the height and width described. I've always just used square images or videos. And I think there's only a couple other things we need to change. So one is the frame buckets. We're only doing images, so it's basically a 1-frame video is what it's treating it as. I haven't tested a lot which frames this works best. I know the natural amount of frames the model expects is 81, so that may be a good starting point. Genuine used 33, so if you want to play with that one and let us know in the comments what frame buckets worked for you, then that would be awesome. Our path to our images or videos, we haven't uploaded our images into our environment yet, so we have to do that now. All right, so I have my training images here, just in a folder called training images. I'm going to copy that and paste it right into my Diffusion Pipe directory. All right, so now I have training images in my Diffusion Pipe directory. I have my files with their related caption file, and now all I need to do is put the relative path in here. So just training images. All right, so the relative path is the name of the folder relative to the base directory. So we're treating our base directory as Diffusion Pipe because that's where our config files are, and that's where we're going to be running it from. So if you had something deeper, like if I had another folder layered in here, I would have training images / other folder would be my relative directory. Okay, and then the last thing that we need is to set the number of repeats. Because we're not using regularization images, you might even just be able to put 1 here, but that gives you like tons of epochs. So I usually put this like 3 or 5. We can leave it on 3 for now. Okay, so that should be everything that we need. At the bottom of the install script, I put these command line prompts for running the training. So we already activated our virtual environment. And then the next thing we need to do is run this command here. The only thing we need to change here is where the file is. So when I had done my testing, I put the wan2.1 inside of an examples folder. But here it's just in the root directory. So I'm just going to delete this examples folder. And then we are going to train, and let's see if it works. Sorry, when I was giving you guys the example of the double brackets, I forgot to remove the double brackets around my 512. So if you're just using one square resolution, make sure it's in single brackets. All right, so this is a good sign that it's mapping our images, and here you can see that training started. All right, and you can see how fast training runs for this model, especially with the images. It's really fast. I think even when I was training 81 frames and trying that out, it was like 30 seconds per step, which is, I think Honeyman was 30 seconds per step for 33 frames. Okay, so the last thing I'm going to show you how to do is how to set up a Tensorboard for this so you can see your progress and see how the training is going. So you'll need to navigate to the directory that you set up here. So wherever you're outputting your Lora files, navigate there. This is that directory for me. And I'm going to open a terminal in this location. And then I just want to see if I have Tensorboard installed already. Okay, I don't have Tensorboard installed. So I actually want to, you can either do pip install Tensorboard if you have a global Python, but I want to use the Python from Diffusion Pipe. So what I'm going to do is copy the path to Diffusion Pipe, paste that in here. And then I'm going to activate the virtual environment from Diffusion Pipe. And then I'm going to go back to my training, or where my Loras are being outputted to. Okay, so there's two files in here. One is from yesterday and one is from today. The 228 folder is the one from today, so that's the one I want to navigate into. All right, and then you can see this events.tf or events.out.tf events. This is what's going to give us our Tensorboard information. So in order to run Tensorboard, all you need to do if you're not navigated into the folder where your Loras are being outputted is do Tensorboard --log dir space dot or period. All right, and now Tensorboard is set up. If you're on cloud, you can just use ChatGPT to give you the Tensorboard command to host a Tensorboard on one of your exposed ports. So I'm just going to use my localhost link here. Click that. And here we get our training progress. All right, so what we're really looking for is, typically I see, this isn't a hard and fast rule, but typically I see the best Loras come like just under 0.02 epoch loss. You'll start to see once it gets down to like 0.01, you start to see some overtraining. Again, that's not a rule, but that's generally what I see. It's always just important to give yourself some sanity testing on either side of that to make sure. So once your testing is finished, we're going to be taking a look at these local minimums. This is typically where you see your best epochs because it's the lowest loss for, that stage of training is what you're looking for. You don't always want the latest epoch because sometimes that's overtrained. And then usually the early epochs are undertrained. So we want to find a spot in the middle and then find the best epoch of that spot in the middle. Okay, so once our training finishes, I'll meet you back here and I'll show you how to use Tensorboard along with Comfy UI to test your epochs. Okay, so my training has finished here. We went through all 1,000 epochs, and this is our Tensorboard. Okay, so if you haven't used Tensorboard before, this is a way to test your Loras or, get an idea of which Loras you should test without having to, I have 1,000 divided by 5, 200 epochs here. There's no way I'm going to be able to test all of those. So I need to find a way to break it down into testable pieces, and this program will help us do that. So I hope that you have Comfy UI up already and you followed my advice in putting the Loras into your Comfy UI Lora folder. It just makes it way easier to test them and not have to move a bunch of files over. So let's take a look. First, I want to let's baseline ourselves, right? So bypass, and I'm just going to say, use my trigger word and man walking, and let's see what our output is. So you can see we have color, some skin color here. It's a normal looking person walking towards the ocean here. So now we're going to take a look at our Tensorboard and try out some of our Loras to see what effect the Lora had on this image. So burn that into your minds. Let's do some more testing. Actually, I'll pull up that video in the background here. That way we can compare it. So there is our non-Lora video. So now let's take the bypass off and let's take a look at our Tensorboard. So remember that I trained this with, I believe, 4e to the negative 4. Yeah, with 2e to the negative 4. So that's probably a bit higher than I would recommend. We got convergence really quickly, which means we could probably lower the training rate, maybe like 5e to the -5 or something like that. And you should still see convergence in a relatively quick time period using images. All right, so I want to look around this part here where it kind of leveled off. Maybe somewhere around this. I have step 339. I only saved every 5 epochs, so I only have numbers divisible by 5 testable. But 339, so that's step 340 I want to test. So that means that's epoch 340. All right, so let's go to Comfy UI and let's try out 340. And remember, I'm using the same seed so that we can really test, how much did the Lora change our output? And hopefully the answer will be quite a bit. All right, so here is our generation. And so remember, this is more of like a style Lora. It's not really a character Lora. We are really expecting a similar generation, but just with the style of the stick figure images that I generated, or that I drew by hand poorly. So it does a pretty good job of that. You can see like it maintains the motion pretty well, but then just kind of replaces it with that black and white style. So I actually like this epoch quite a bit. Let's test a few more. I especially want to show you ones that are kind of too burnt and they don't give you motion like this. All right, so that is 340, I believe is a good one. Yep, 340. Okay, so now let's see. Let's look a couple after that. Here, over here we have 400. Let's take a look at 400. And I'm looking for like these local minimums. Sorry if I forgot to mention that before, but I'm really looking for these local minimums to see if these are usually an indicator of you may find a good Lora there. So that's why I chose 400. All right, let's give this one a go. All right, so this one is potentially looking a little bit burnt to me, just with some of like the weird movement, and then just the fact that it is having some trouble mimicking the movement from the original. So let's take a look at another one further down the line and see if that is in fact true. Let's try out 455 here. Actually, no, 460. We'll try 460. That's a pretty good local minimum. Yeah, so 460 is a decent local minimum there. All right, so this one, the clarity is not too bad, but it's really replacing that original movement that we got in this video. And we want to be able to maintain that movement. So that's why I would still prefer 360 over this one. Let's take a look at one more. I just want to show you one that's like super burnt out. Let's look at 895. All right, so yeah, that's a telltale sign that it's too burnt out. You get almost no movement. You know, the figure looks a lot like the images, like even the pose looks a lot like the images. You obviously want the Lora to look like your images, but you don't want it to mimic the pose of the images consistently. You want it to be able to be dynamic and fit what the model's trying to do while maintaining the style or the likeness that you're going for. All right, so I think 360 is our winner right now. Let's just go back and look at one other one from earlier in the training. We can go for 255. Let's give that one a shot. So again, that local minimum 255. I really like this local minimum strategy in Tensorboard. It has given me great results so far. All right, yeah, so for me, this one's it's close, but it's a bit undertrained, right? Because we got a more realistic looking person. We didn't get that, perfect black and white generation like we got with this one. I hope that helps a little bit with the testing and what you're looking for. You're just really looking for maintaining your style, but allowing the model to be flexible, because it's easy to find one that maintains style, but in order to get it to follow prompts, that's where the art comes in testing, the ability to test really well comes in. So obviously when you're doing your own testing, you should try more than one prompt. I usually try to get using this strategy, I try to get maybe 5 of my favorites, and then I'll test each one with a different prompt, and I'll kind of eliminate them as I go until I have one that I like the best. Okay, so that is it for this video. I hope all of you are having fun with Wan. I've been really enjoying diving into it and taking a look at some of the code and some of the projects that people are working on. If you're interested in that type of thing and this type of AI generation content, join the Discord. We have a bunch of people in there asking questions. People are posting new models when they come up. It's been a really great place to be one of the first to learn about some of the new cutting edge AI stuff that is coming out. So I hope to see you there. Follow my other socials, and I appreciate you watching this video. I'll talk to you again next time.